Okay, so today we'll solve two questions from real analysis. Question number 39 from Gate 2022 and question number 36 from Gate 2021. Okay, I'll play the video. Okay, let's first see question number 39 from Gate 2022. Okay, so today we'll solve Gate 2022 question from real analysis. This is the question number 39. So two statements are given. The statement P is saying that suppose a power series is given and saying that it converges. I think there is some internet problem. Okay, wait, just wait. Real analysis. This is the question number 39. So two statements are given. The statement P is saying that suppose a power series is given and saying that it converges at x equals to -3 and diverges at x equals to 6. Then the series -1 to the power n converges. So this is the statement P. The statement Q is saying the interval of convergence of the series given by this is -4 to 4. So these are the two statements and 4 options are given. You have to check which one is correct. Okay, and this is the NPTEL reference. Okay, so let's try to solve this one. So let's first recall what is the interval of convergence for power series. So given a power series, summation Cn x to the power n, put this number, call this to be alpha, this is lim sup of Cn to the power 1 by n, and put R to be 1 by alpha. So if power series is given and if you define this R to be this one, then what it is saying, then summation Cn x to the power n, this power series converges if mod x less than r and diverges if mod x bigger than r. So it's saying that if given a power series this, if you define R to be this 1 by alpha, where alpha is this, then the power series converges for mod x less than r and diverges for mod x bigger than r. So then these are basically, then note this R is called radius of convergence. Radius of convergence. Okay. So what is the first one? It's saying that, so and inside the radius of convergence it is saying that the power series converges, and outside radius of convergence the power series diverges. So what is the first option? It's saying that the power series converges, and also there is a one thing that, so basically R is the maximum number inside which the power series convergence. So outside this R, for any x, if it is bigger than R, then the power series will not converge, right? Okay, so it is saying that the power series is converged at -3 and diverged at -6. Here summation an x to the power n, this converges at x equals to -3 and diverges at x equals to 6. So note that here converges for mod x less than r. So if it is converged at x equals to -3 means, because mod x here is 3, so it will also converge for x equals to 3. So therefore this series means it will also converges at minus at 3. So because it is converges inside, so it is 3 and minus 3. So it's because r is the biggest number in which this is convergent, so it has radius of convergence must be less than 3. So therefore the radius of convergence, the radius of convergence of this series must be bigger than 3, right? Bigger than or equals to 3, or converges at 3 means it should be bigger than 3, means at the point 3 it is also converges, or less than, it might not be converges at 3, less than equals to 3, bigger than or equals to 3, or equals to 3, right? Summation n x to the power n converges for, so this we can say that this will converge certainly for mod x less than 3, because at the point minus 3 it is converging. So so inside mod x less than minus 3 it will converges, right? So this we can say at the point 3 we may not be, because at the point 3 may not be converged, but inside 3 it will certainly converge. Because of this. Now what it is saying that the series minus 1 to the power n will converge or not. To check this series equals to 1 to infinity minus 1 to the power n converges or not. So note that what is this? If you put x equals to minus 1, you will get this one. And you know for mod x less than 3, this series convergent. So at the point x equals to, this series also convergent. As we know, at x equals to -1 summation an x to the power n converges by star, let me call it star. This is by star, right? So therefore you can take x to be then. So at x equals to -1 an -1 to the power n converges. So this is what we have to find. So therefore this series, the first one, then this series will converge. So the first one is done. And what is the next one? It is saying that the interval of convergence of this series is -4 to 4. Just wait for 1 minute. So a series is given for n equals to 2 to infinity -1 to the power n x to the power n by 4 to the power n log e of n. So you have to find the interval of convergence. Means if the inside this where this will means convergence. Oh yeah. So here the interval of convergence. What is the interval of convergence? And interval of convergence is minus r to r, because at the point r we don't know. If we know that at the point r and minus r is convergent, then we can take it the closed interval minus r to r. Now you have to find the interval of convergence of this series, power series. So from this is also saying that what will be the radius of convergence, this formula, right? So we'll use this formula to find out the radius of convergence. Then we'll find the interval of convergence. So therefore, what is, so first you have to find alpha. What is alpha? Lim sup of n tends to infinity. So suppose if this is n equals to 2 to infinity cn x to the power n, where cn is minus 1 to the power n by 4 to the power n log en. So lim sup of cn to the power 1 by n. Then what is this? Limit n tends to infinity. Lim sup of, what is cn? So this one minus 1 to the power n by 4 to the power n log e of n to the power 1 by n. So this is basically lim n tends to infinity. So this is the limit, because lim sup of don't need, because n bigger than, so it will be basically 1 by 4 log en to the power 1 by n. And this is basically you need to find on the limit of this one. Limit n tends to infinity log n to the power 1 by n or 1 by. And if you find this limit, what is the limit of this one? A log n to the power 1 by n. You can show that limit of this is 1, so basically you will get 1 by 4. Here, no, this you can check that limit n tends to infinity log n to the power 1 by n, this is 1. So therefore you will get alpha to be 1 by 4. So then what is r? R we have defined this to be 1 by alpha, means 4. So this is the radius of convergence. And so we can say that inside 4 it will certainly converge, but what happened at the point 4 and minus 4? Because here it is saying that the interval of convergence is closed interval minus 4, 4. So we have to check again 4 and minus 4. So let's check it at minus 4. At x equals to minus 4, what will happen? Summation n equals to 2 to infinity minus 1 to the power n. So this is x equals to minus 4. So this, and what is this? 4 to the power n log e base n, right, this one. So if you simplify this one, you will get n equals to 2 to infinity minus 1 to the power 2n, 4 to the power n by 4 to the power n log base n. So if we again simplify, you will get n equals to 2 to infinity 1 by log e base n. And you can show that this series is, because n from n equals to, this is a series of positive real number, and this you can show that this is bigger than 1 by n, right? Because log is less than n, so this is bigger than 1 by n, and this is divergent, right? As summation n equals to 2 to infinity 1 by n diverges, so therefore this will also diverge. N equals to 2 to infinity minus 1 to the power n minus 4 to the power n. Note that this is a series of positive real number. That's why you can use the comparison test. Will also diverge. So at x equals to minus 4, the series n equals to 2 to infinity minus 1 to the power n x to the power n by 4 to the power n log e base n diverges. So the interval of convergence, so interval of convert cannot be closed interval, so the interval of convergence for this series is minus 4 to 4, right? Because at the point minus 4 it is not convergent. So this is the interval of convergence. So therefore which one is correct? The first one, because this is convergence and the interval of convergence is not the closed interval minus 4, so therefore Q is false and P is true. So therefore P is true and Q is false. C is true. Okay. Okay, any question? Or doubt? Okay, then we will move to the next question. Okay, so today we'll solve Gate 2021 question. This is a question from real analysis. This is question number 36. Saying that like FNBA sequence of function is given. It's defined by fnx equals to nx cube into e to the power minus x, power n belongs to natural number. and then the two statements are given saying that Fn is equicontinuous, means this family is equicontinuous in the interval 0 to 10, it's compact interval. And statement Q is saying that summation n equals to 1 to infinity Fn does not converge uniformly on 0 to 10. Okay, so then four options are given, that which one is correct or which one is false, you have to check. So this is the question. In order to solve this is the NPTEL reference, this you can check. Okay, now let's start to solve this one. So let us first recall what is the definition of equicontinuous. Let me recall the definition. Equicontinuity. Okay. So first let this is scripted be a collection of real valued continuous function, be a collection of real valued continuous function on a, suppose let's do it for one metric space, you can do it for R or because they are metric spaces. On a metric space X, let's say. Now what is the definition? So F is a collection. So say equicontinuity is saying that when means Fn is a collection of continuous, it has a collection of continuous function. When saying that when these all collections are means, yeah, it is saying that this, it taking over the continuity of this collection. So we say F is equicontinuous if for given epsilon greater than 0 there exists a delta greater than 0 such that whenever x and y belongs to x satisfy such the distance of xy is less than delta, we have mod of fx minus fy is less than epsilon, and this is true for all f in this collection. So what it is saying, so given any epsilon, Just wait for 1 minute. It is saying, so given any epsilon greater than 0, there is a delta. So for all xy means, so this delta does not depend on xy. So that whenever x and y are very close, means d of x comma y is less than delta, we have mod of fx minus fy is less than epsilon, means fx and fy are close. So what is, so note that what is the difference. So there are three type of continuity. First you learn that pointwise continuity. What it is saying that for a fixed an x and given any epsilon, there is a delta which may depend on this x, right? So this is the pointwise continuity. Therefore, pointwise continuity, delta may depend on x. And now then later come that uniform continuity. Then it is saying that in the interval or wherever you are doing, so given any epsilon greater than u, there is a delta. So this delta does not depend on xy. such that whenever x and y are very close, minus fy is less than epsilon. What is the pointwise continuity? What it is saying that which pointwise continuity? What it is saying that for a fixed an x and given any epsilon, there is a delta which may depend on this x, right? So this is the pointwise continuity. Therefore, pointwise continuity, delta may depend on x. And now then later come that uniform continuity. Then it is saying that in the interval or wherever you are doing, so given any epsilon greater than u, there is a delta, so that it should not depend on the point x. It should hold for all x, you get a single delta, right? So this is the uniform continuity. And here it is, what is saying that equicontinuous? It is saying that for epsilon greater than 0 and f is a collection is given, means many functions are there. It's saying that you get a delta which should not depend on x and also f, means it should be independent on x and f, means this delta should work for all x and for all f in the collection, right? So this is the difference between pointwise continuity, uniform continuity and equicontinuity, right? Now what we have to find? We have to find that this family is equicontinuous on 0 to 10 or not. Okay. So for that I will use one result that you can prove easily. I think I will give you some idea. So what is the result? The sequence of function. Let fn be a continuous function. Let us start with this. Let fn be a sequence of continuous function. If fn converges to f uniformly, x be a compact matrix space, and this is on x. Right. So what is saying that if x be a continuous function and fn be a sequence of continuous functions, a compact matrix space, let x be a compact matrix space and fn be a sequence of continuous functions on x, then if fn converges to f uniformly, so what is there mean? If n converges to f uniformly means in this for all x such that we will get a natural number n such that fn minus f should be small for all n which is bigger than this capital N and for all x, right? So this is the meaning fn converges to f uniformly. Then saying that if this happen, then you can say that this collection means the sequence of function is equicontinuous on X. Right. Okay, so for this, let me give the hint how to you can prove, or you can prove it also. So use two things that, or just use the definition of first hint number one. Use definition of uniform convergence. Suppose for all y, it's saying that an fn minus fny minus fy is less than epsilon. So that for all small n greater than some capital N. Right. So basically, here you will use this one. So that for all n, for all y, and for all n bigger than some capital N, it will there is some capital, which will imply mod of fny minus fy is less than epsilon. Right. So this one use this, and second use that because here fn is sequence of continuous function. If they converges uniformly, then f will be continuous. Right. This is the standard result. So f is continuous, and this is compact matrix space. So f will be uniform continuous. Continuity of. So what is this meaning? Meaning that for some delta dash bigger than 0, such that for all y and all x belongs to x, such that if d of xy is less than delta dash, which implies mod of fx minus fy is less than epsilon. So let me call this by epsilon by 3 technique. Let me write epsilon here, epsilon, right? So use these two, then use these two, and just what you have to prove that fn minus. So to prove, so these are the two hints. And a sketch of the proof. So what you have to prove? Note. You have to prove that. What is the definition of equicontinuity? To prove that given epsilon greater than 0, there exists delta such that whenever xy belongs to x, so when distance of xy is less than delta, fx minus fy is less than epsilon. So given epsilon greater than 0, there is a delta bigger than 0 such that for all xy in x, e of minus fny is less than epsilon, right? So this you have to prove. So here what you will do, then just write this one, fn minus fnx minus fny. How you will write this one? You will just use write this fnx minus fx plus fx minus fy plus fy minus fnx. So what I have done, I have just add and subtract this one and add and subtract this one. Now what I will do, I will use the triangle inequality. So fnx minus fx plus fx minus fy plus mod of fy minus fny, right? Now note the by hint 1, if you use this, sorry, if you use this one, you can make the first term fny fnx minus this to be less than epsilon, so I will take epsilon by 3. And the second term, by the uniform continuity app, you can make this to be less than epsilon whenever d of xy is less than delta dash. And the third term similar to the first term, right? This is true when xy are less than delta dash, right? So whenever is less than delta dash, right, for some delta dash. And for the first two term, what you will get from these two term, you will get for all n bigger than some natural number, all n. So you will get this for all n bigger than natural number and dxy less than delta. But what you have to show, this is less than epsilon for all fn, right? Here n is all natural number. So you have only remain with finitely many. And so for finitely many, what you will do, because you know each fn's are continuous, so for f1 you will get now. So you have only remain with this one, f1, f2 up to dot 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 fn minus 1. So what you will get some, because f1, so you need f1 minus f1x minus f1y to be less than epsilon, so get some, because they are continuous, delta 1 such that d of xy whenever is less than delta y, you will get f1x minus f1y is less than epsilon, right? So similarly for, you will get some n minus 1 delta n minus 1 such that whenever d of xy is less than delta 1. And note that they are uniformly continuous, each fn, right? Because x is compact matrix space. You will get fn minus 1 x minus f of n minus 1 y. This is less than epsilon, right? Now what you will get, what you will do, so now you will take delta to be minimum of all this, minimum of delta 1, delta 2 up to dot dot delta n minus 1 and delta dash. Then for this delta, then for this delta, we have, so this is for n bigger than capital N, and this is for up to n minus 1, fnx minus fny is less than epsilon whenever d of xy is less than delta and for all fn, right? So this is the proof basically for this statement. Okay, so this result, now we'll use this result to prove our, so what we have to prove, that fn is equicontinuous on 0 to 10. What it is given, so note this, you can write, right, 1 plus nx plus n square x square by factorial 2 dot dot. Now let's, here we only need x greater than 0. What is, so e to the power x cube by 3 means that n x cube, so this is bigger than or equals to n x cube, or it will be strictly bigger than, right? E to the power minus x, take to be this side, you can write this to be less than 3 factorial by n square, right? So if you simplify, you will get this one, and this is the fnx, right? So what we have to show? So first note that, so this is the, you will use this estimate, xx e to the power minus nx, this is goes to 0, e to the power minus s, n by e to the power n will goes to 0. So for each x fixed, this goes to 0. So that this is uniformly convergent to 0 means, and this is n x cube e to the power minus x nx, and what we have got, that n x cube e to the power minus is less than 3 factorial. Note that this we can make, this is x independent, right? So so this does not depend on x, and this we can make so sorry, this is n square. So given epsilon, you can some x multiple n, capital N, because it's only independent of x right hand side, so which implies 1, because we only know 0 to 10, so this. So you've got that fn converges to 0 uniformly on 0 to 10. Now what is this theorem is saying? And we have also compact matrix for 0 from, because 0 to 10 is compact matrix. So then by this result, we can say that fn's are equicontinuous. So you have from 0 to 10. And what is the next one? It's saying that summation fn does not converge uniformly on 0 to 10. And this is also easy, just here use the, for the next one, use the worst sum, such that there exists a positive sequence of positive real number, right? Positive real number, such that condition mn for all n belongs to natural number and x belongs to x. Condition 2 is saying that the series of mn should converge, then converges and uniformly. On x, right? So here x, what we have for x, what estimate we have, because we have to estimate this one. So what we have got, right, because fnx we have shown this to be 3 factorial by n square as this one, and we know 1 by n square, sorry, these are n square, always I'm writing n factorial. This so because this series converges, so the Weierstrass same test, summation fn uniformly on 0 to 10. Which option is correct then? Both P and Q are true. So P is true, but it is saying that summation fn does not converge uniformly, so Q is false. So therefore option number B is correct. P is true and Q is false. Okay. Okay, so I have done 2 questions from, one is from question number 39 from 2022 and question number 36 from 2021. Okay, bye then. Let's meet in the next week. Bye.